everyone. This will be the virtual session for the mid-module check for Module 1. And this should be a 7th grade one, so if you are in the wrong one, please get out of this one and go find the one that you need to watch. I'm going to go ahead and turn off my video here so you don't have to stare at my face while I do this, but hopefully this will help you understand the Module 1 a little bit better. At this point, you should have already done some of the lessons and should be ready for the mid-module check. So this is the reflection sheet that you will fill out based off of this virtual session. So make sure that you have this open or printed off so that you can write on this as we go. You should also have a piece of paper and a pencil so that you can write out some other problems to just be trying them if they aren't the ones that we're going to be writing on the reflection. The topic today is going to be, we're working on number line, and we're working on adding and subtracting rational numbers. So you can put that in the topic, and then whatever date you're watching it. In this middle part here, you're going to write in detail what we did in complete sentences. I know this is math class and you don't feel like you should be writing, but it's very important that you practice your writing with all that you do. So give me some complete sentences to show that you've watched this whole thing. And then throughout the virtual session, I'm going to do 3 problems, and I'll have them labeled which ones you're going to put in here. So you'll put the problem up in this dark blue, you'll show all the steps to solve it in the light blue, and then put the answer in the lightest blue down there. All right, so let's get started. Some of these problems I took directly from the mid-module check, so you might see them again, but how the tests work in math classes, it draws from a huge bank. So you might not see this exact one, but you'll see similar ones. So it's a good way to go over before you take the module test. All right, so the first thing we're going to talk about is number lines and how to use them with integers. So if you are having a hard time adding and subtracting integers, using a number line is a great resource to help you understand them a little bit better. So what we're going to do is we're going to be matching these expressions with the number lines that they go to. All right, so I'm going to be looking for a -4 plus a -3. So what I want to look for is it's going to start, my number is going to start at 0. We always start at 0, and I want to go all the way back to -4. So both of these ones right here say that they go back to -4. See, we started at 0, we went back to -4, started at 0, went back to stopped at -4. The next part of my problem, though, says minusing 3. Whenever we're subtracting, that means we're going to the left. Whenever we're adding, we're going to the right. And even though it has an addition symbol here, we can pretend that's not there and pretend that our negative becomes a subtraction because they're the same thing. So we actually want to go to the left 3 more. This number line looks like it goes up 3 more, so that would be adding 3. This one down here looks like it goes down 1, 2, 3 more. So this expression would match that number line. So my answer to -4 plus -3 would be -7. All right, so for this next problem, the next problem says 4 plus 3. Well, you probably don't need a number line to tell you that 4 plus 3 is 7, but if we're using number lines to show it, then we need to make sure that we're in the positive. So we're going to be starting at 0 and going up to 4. So both these two have our first line starting at 0 and going up to 4. Starting at 0, going up to 4. And then we're going to also add 3. So again, adding is going to go to the right. This one goes 1, 2, 3 to the right. This one goes 1, 2, 3 to the left. So that would be subtracting 3 or adding a -3. So this expression would match this number line. Go ahead and pause this and try the other two on your own and see when you unpause them if you get it right. All right, this third expression here, we're going to start at 0 and go to the left to the -4. So remember, both of these do that. So we go 1, 2, 3, 4 to the left. And then plus 3 means we want to go to the right. So here we're going to go to the right 1, 2, 3. So the answer of -4 plus 3 would be an answer of -1. So that would match this one. And last but not least, we have a +4 plus a -3. So again, we want to start at 0, go up to 4. So we've got these two that do this. And then plus a -3. Any negative or minus is going to have us go to the left. This one is having us go to the right. So this one is having us go to the left 1, 2, 3. So we have a sum of positive 1. Hopefully you had a chance to pause those and got them all right. All right, the next thing we see are additive inverses. So we're just going to be doing the same thing. We're going to be trying to figure out which number line answers this problem here. This number 1 indicates that I want you to put this on your reflection sheet. So the problem just says rewrite 7 minus 8 using a number line. If you just want to write 7 minus 8 with a number line in your equation thing, you could put that there, and then you could draw out the number line for your answer, and then we'll solve it for the end. So for that first box, you're just putting 7 minus 8 on a number line, and then for the second box, you're going to actually draw out the number line. So let's see, if we start with 7, we need to start at 0 and go up to 7. So that one's good. This one starts at 0 and goes up to 7. That one is also good. This one starts at 0, goes up to 7. That one's also good. This one starts at 0 and goes up to 8. So we know that this one is incorrect. All right, for the next part, if we're saying minus 8, that means we need to go to the left. So this line right here keeps going to the right. This line right here keeps going to the right. So we know that this top one is probably going to be it. Let's check it out though. So we're at positive 7, and now we're going to be going to the left 8 spots. 1, 2, 3, 4, 5, 6, 7, 8. All right, so this is the number line that you need to draw. Let me clear all this stuff off of here so it makes it a little easier to see. So draw out this number line in your second box. And the answer is where we end up. So if we end up here, that means our difference is negative 1. 7 minus 8 would be a negative 1. All right, the next thing the module talks about is absolute value. Absolute value means the distance away from 0 on a number line. So our answer is always going to be positive because we're only going to be away from it either 4 units or 3 units, even though this one is a positive number and this one is in the negatives. We're still that far away from the 0. We're still 3 steps away from the 0 there, so it's still positive. They write absolute value using these little lines like this. So in that first example there, it shows a negative 3. So it's saying on a number line, how far is a negative 3 from the 0? Well, it's 3 spots from the 0. So our answer would be 3. So our answer is always going to be a positive number when we're dealing with absolute value. All right, so the question here says, use absolute value to express the difference between negative 10 and 16. All right, so negative 10, the absolute value of negative 10 would be an absolute value, meaning how far is it from the 0 on a number line. So if we went all the way to negative 10, it would be 10 spots away from the 0. And then the absolute value of a positive 16 would be on the right side of the 0. So it would go all the way up to 16 way over here. And that means it would be 16 spots from the 0. So it would be a positive. So we want to know, use the absolute value to express the distance between those two. All right, so we have 10 plus 16 because we're way down here on this side of the 0 and we're way up here on this side. Oops, that doesn't look like a 16 there. Let me fix that. So we have 10 plus 16, which is 26. All right, so we have a difference, or I'm sorry, a sum of 26 there. That means that we have all that spot in between them. So that's a way to use the number line to understand adding and subtracting negative numbers there. This is just another number line to show you how we did it here. So if you like this example, it would be a great idea if you could screenshot this and print it off for your notes, because this might help you when you refer back to what you're doing using the number line, if that's how you like to use it. So they have a negative 3 plus a negative 2. So again, they started at the 0 and they went back 3. And then this is saying that they're also going to go to the left since it's a negative. Then we go back to the left 2 more, and we end on a negative 5. So the sum of negative 3 plus negative 2 would be a negative 5. All right, I put this song on the first video that I put in the module 1. This song is the thing I refer to. I don't necessarily love using the number line. If that works for you, great. I use this in adding integer song when I add. Okay, so you sing it to row, row your boat, and excuse my voice because I'm not the best singer. It goes like this. Same signs add and keep, different signs subtract. Keep the sign of the highest number, then it'll be exact. All right, so sing that over and over, get it stuck in your head. We will do that a lot in-house anyway because it's a great song to refer back to. So let me show you how we're going to use it when we practice some integers here. At this point, if you're ready and you understand adding integers or subtracting integers, you might want to take out a piece of paper, pause the video, and try these numbers first. Then unpause it and see how you do. All right? Okay, so one of the rules when you're adding or subtracting integers, when you subtract, you should always make it into addition problem. I always say when you have a negative and then a minus something, let's just say this is a minus x here. So let's say we have y minus a negative x. So whenever you have a minus and a negative, what we're going to do is make that into a big old plus sign, all right? Because we always want to change our subtraction into a plus sign. Then our song always applies. All right, so I'm just going to make that a double negative makes a positive. Okay, they always say 2 wrongs doesn't make a right, but in this case, we're going to make it a positive. So I had a minus and a subtraction there, so I'm just going to make it a big old plus sign. I know 3 plus 5, which would equal 8. This is an easy one. 8 plus 7, you should all know that, is 15. Oop, my pen stopped working there. Okay, so then number 3. Now we have a plus and a negative. So let's go back to that song that I just sang. Same signs, add and keep, different signs, subtract. Okay, this is a positive sign because there's nothing there. Whenever there's nothing there, that means a positive. Sorry, that was supposed to be a big old plus sign, but it's so small it doesn't really show up. All right, so we have a positive 15 and a negative 8. So we have different signs. So whenever we have different signs, the song says to subtract. Same signs, add and keep, different signs, subtract. So 15 minus 8 would be 7. And then our last line of the song goes, keep the sign of the higher number, then you'll be exact. This is a bigger number. 15 is a bigger number than just our whole number 8 there. All right, and 15 is positive, so that means our answer is going to be positive. So we have a sum of positive 7. All right, number 4 is going to be just like that. So we have same signs, add and keep. They're not the same signs. Remember that 5 is positive since there's nothing in front of it. Different signs, subtract. So we have different signs. 12 minus 5 is 7. But then our last thing says keep the sign of the higher number. 5 is less than 12. Okay, remember we're just working with the number. We're forgetting the signs when we say that, okay? Same signs, add and keep, different signs, subtract. We did that. Keep the sign of the higher number. So 12 is our higher number, and it was negative. So now we're going to have an answer that is negative 7. All right, number 5 should be easy. We both have the same signs. They're both negative. So same signs, add and keep. All right, so 2 plus 8 is 10. We're going to add them up, and keep means keep the sign that it has. So they're both negative, so we're going to leave at negative 10. Number 6, again, sing the song. Same signs, add and keep, different signs, subtract. We have different signs. We have one negative, one positive. So we're going to subtract. 12 minus 6 is 6. Keep the sign of the higher number. We have a 12 and a 6. Well, 12 is our bigger number, and it's negative, so our answer needs to be 6. Keep the sign of the higher number, then it will be exact. Number 7. Same signs, add and keep, different signs, subtract. 16 minus 8 is 8. Keep the sign of the higher number. 16 is our bigger number. 16 is bigger than 8, and it is negative, so it makes my answer negative. Hopefully these are getting kind of repetitive and getting easy for you. This should be an easy one. These are inverses anyway. If we have negative 13 and we have a positive 13, they equal each other out on the number line, so it should just be 0. But if you weren't sure with that, you can always just sing the song. Same signs, add and keep, different signs, subtract. So 13 minus 13 would be 0. And then you don't make a 0 negative at all, so it will always be, I guess there really isn't a positive or negative sign for that, so it will just be 0. All right, here is our number 2 for our reflection sheet. Go ahead and put negative 15 minus 5 on your reflection sheet as the problem. Now remember what I said for number 1 here. Whenever we have a subtraction problem, we want to make it an addition problem. All right, so if I have negative 15, to make that an addition problem, all I need to do is add an addition symbol in here. So we're going to say plus, and then that what it looks like is a minus becomes a negative. Remember, a minus and a negative are the exact same thing. So we're just going to scoot it over a little bit, and then we have negative 15 plus negative 5. All right, so we just basically added a plus symbol right in there, and then scooted that minus over to make it a negative. All right, so that's how we will make it into a plus sign. An addition problem, and now we're going to sing our songs. So we have same signs, add and keep. Hey, they're both negative, so we're going to add them. And remember, keep means to keep the symbol. So since they're negative, we're just going to keep it a negative. So our answer to that would be negative 20. Hopefully that all makes sense. If not, let me know, and I can go over it again for you. All right, rational numbers here. Rational numbers, we use fractions a lot for this, so if you're not familiar with fractions, make sure you're letting me know, or go back and review the lesson before you go over this, or go over this and then go back and review the lesson to get a little bit of extra practice. With rational numbers, with fractions, you have to have common denominators when you add or subtract. In this case, we already have common denominators. So we are going to go ahead and do what it says. So it's going to add. In a fraction, you always just keep the denominator the same. So I can go ahead and keep that denominator. So now what I'm really working with is I'm really working with 1 plus negative 4. All right, because our denominators kind of just go to the bottom anyway. So now don't worry about that denominator. Don't freak out because it's a fraction. That should be easy if they have common denominators. Okay, so now we're back to what we just did. Same signs, add and keep, different signs, subtract. These have different signs. That 1 is positive, the 4 is negative. So different signs, subtract. 4 minus 1 is 3. I'm going to put that up there. And then keep the sign of the higher number. 4 is bigger than 1, so we want to make it a negative. So my answer here is negative 3/5. Again, you can check that on your calculator if you want. If you don't have a graphing calculator or a little bit bigger of a calculator, you might not have parentheses symbols, but you would have to put that in parentheses to make that work for fractions. I can show you how to do that in-house sometime if you are still confused. Okay, just like on the last page, now we're on number 3, so this is going to go on your reflection page. But just like on the last slide that we just did, we have a minus. Remember, I want to make all my problems additions so that I can sing my song. So we have a minus and a negative. Remember on the last page I told you if you have 2 wrongs, it makes a right on math. So I'm just going to make this a giant plus sign. So now my 10 and 1/6 actually becomes positive. All right. So now I can do this 2 different ways. I can say we have negative 2 plus 10, and then I have 1/3 plus 1/6, and then I can add those 2 answers together. Or if that confuses you, you can do the around the world and make improper fractions and add them that way. So I'll do it both ways. So let's start with what I've got down here. So I have negative 2 plus 10. So same signs, add and keep, different signs, subtract. 10 minus 2 is 8. Keep the sign of the higher number. We're going to stay positive. Okay, with fractions, you have to have common denominators. So I can't add those yet. So to get a common denominator, I'm going to multiply this side by 2. Whatever I do to the bottom, I have to do to the top. So 3 times 2 is 6. 1 times 2 is 2. So now I've got 2/6 plus 1/6. Remember, our denominator just stays the same. And 2 plus 1 is 3. And then that would simplify down to 1/2. Okay? All right, so now let's show you the other way, and then I'll show you how this all works out. So if I did around the world, I'm going to take 3 times negative 2, which would be negative 6, plus 1 would be, if I'm at negative 6 and I add 1, remember I'm going to the right on the number line, so I'm at negative 6 plus 1 would be 5. So I have 5/3. And I'm adding my 6 times 10, which is 60, plus the 1, which is 61. See, this might be a little bit more difficult because now you're working with much bigger numbers. So you might want to just stick with the first way. All right, except for I need to make this a negative, don't I? I think I did that wrong. I'm so sorry. I need to just forget that this is here for a second while I make this here. So I've got 6, 7. This should be a 7. Sorry about that. See, teachers make mistakes too. All right, so we have 7/3 and 61/6. So now I would need common denominators. It's going to make this a lot more difficult because I'm working with a lot bigger numbers. But again, I'm just going to multiply that times 2. So I've got 14/3, and that's 14/6, sorry. And that's a negative. And then I've got my plus 61/6. Remember, my denominator just stays the same. So now I've got same signs, add and keep, different signs, subtract. So I have my 61 minus my 14. So I get 47. Okay, 47 divided by 6. 6 can go into 47 7 whole times, which would be 42. And then 47 minus 42, to tell me what's left, would be 5 6s. Oh, I did something wrong here. Shoot. Let me pause this and figure this out. All right, so for this next problem, make sure that you are going to write this down in your reflection page for number 3. So go ahead and write that problem in. If you'd like to pause this and try it on your own first, you're welcome to. Otherwise, just watch. Remember, like I said on the last page, whenever you have a minus and a negative, you're going to make that into a big plus sign because we have a song for addition. So we want to always turn our minuses into pluses. All right, so we can only do that when we have a minus and a negative. If it was just a negative, we'd just add that little plus sign in. All right, so the first thing we want to do is around the world to make these improper fractions. All right. All right, so 3 times 2 would be 6, plus my 1 would be 7. So we would have 7/3, and that's a negative. And then we're going to be adding it to 6 times 10 is 60. So remember, when you do around the world to make it an improper fraction, you're always going to multiply this and then add that. Okay, so we take 6 times 10, which is 60, plus the 1, which is 61, and we keep our denominator the same. So now we cannot add or subtract without common denominators. So I'm going to multiply this first fraction by 2 to get a denominator of 6. So whatever I do to the bottom, I have to do to the top. So I have 3 times 2, which is 6, and 7 times 2, which is 14, and that's still negative. And then we have 61/6 over here. Okay, so remember our denominator stays the same, so we don't have to really worry about that denominator when we add. So now we're having negative 14 plus 61, positive 61. Same signs, add and keep, different signs, subtract. These are different signs because we have a negative 14 and a positive 61. So when we subtract that, you get 47. So now we need to see how many times 6 can go into 47 whole time. Well, 6 times 7 is 42. So I'm taking this improper fraction and making it into a mixed number here. Oh, you know what? Something I forgot to do also is when I got to my 47, I know it's positive because my higher number is 61. So same signs, add and keep, different signs, subtract. Keep the sign of the higher number. So I forgot to mention that, but that would also be a positive 47. So 6 can go into there 7 whole times, which would be 42, and then we count up to 47. So if I'm at 42, to get up to 47 would be 5, and then I keep my denominator the same. So my sum here would be 7 and 5, 6. All right, if that did not make sense, or if you're still confused with this lesson, remember I'm available on Wednesdays for our virtual session. You can log on and work with me on that, or let me know and we can work a different time. Also, coming to in-house is great too because I can go over anything with you there. Have a wonderful day, and I hope this made sense to you. I will see you guys on the next video.